Both of them are identical. So let's try to read something. First problem, we have a floor system. This floor system looks like these beams, this beam, and this one, and this one, and we have continuous and continuous in this side. And this floor system for theater lobby. So the function of this building as a lobby in a theater. So from this information, I can open table for live loads from ASCE, American Society of Civil Engineers, for theaters and lobbies. The live load value will be 100. This is the first thing. So live load on the slab or on this floor equal 100 pound per square feet. This floor consists of 5-inch thick reinforced concrete slab. This thickness of the slab equal 5-inch. Built monolithically with concrete beam. We have a beam connected to this slab, built monolithically with concrete beams spaced 8 feet. So the spacing center line to center line between these beams 8 feet, and it's shown on the diagram. 8 feet. The beam spans 20 feet. So this beam simply supported on this support and this support, the length equal 20 feet. Between simple supports with an overall depth. So this overall depth for the beam equal 30-inch and 16-inch width. This width equal 16-inch. So you need to read the problem carefully and figure out what is the meaning of this information on your diagram. One more time, we have a floor system in a theater lobby. So the function of the building will help you to figure out the live load value from this table. Consists of 5-inch thick reinforced concrete slab. So the thickness of the slab 5-inch. Built monolithically with concrete beams. Spaced, so the spacing center line to center line between beams equal 8 feet. The beams span, so the span of the beam simply supported equal 20 feet. The overall depth, overall, so the total thickness of the beam 30-inch, and the width is 16-inch. Given F prime C 4,500 psi, F yield 60,000 psi. The surface loads on the slab are superimposed dead load. Superimposed dead load. Anybody remember last time I told you what is the meaning of superimposed dead load on the floor? Finishing anything on the concrete slab. So your slab with thickness 5-inch, if you add anything for just finishing on the concrete slab, this called superimposed dead load. Equal 40 pound per square feet. The flexure reinforcement in each beam is 8 bar. Number 8. Number 6. So 8 as a number. Size number 6 bars. So each beam has 8 number 6 bars. So I can figure out the area steel in each beam. Everything is given. So what's the question? Concrete beam dimensions are given. Steel reinforcement is given. Everything is given. What is the question? The question is, do you think this beam are safe? Do you think these beams are adequate to support this slab or this floor system? Because your cross section is given, your steel reinforcement is given, the loading is given, everything is given. So the question is, do you think, yes or no, these beams are adequate to support this floor system? So guys, if you go back long time before, I told you our design philosophy is M ultimate must be smaller than or equal phi mn. M ultimate from loading, from structure analysis. Phi mn design moment for the cross section. So your cross section is given, your steel reinforcement is given, so I can figure out the design moment. Your loading is given, and I can figure out the rest, like life load on weight or something like this. And the beam is simply supported with a span 20 feet, so I can figure out the applied moment from structure analysis. Then finally, I can do a comparison between this value and this value. If M ultimate is smaller than or equal phi mn, these beams are adequate. These beams will be safe. If not, these beams will be unsafe. Did you get the idea? Thank you, Angel. Did you get the idea? So sometimes we need to check your beam is safe or not safe. Let's start. So this problem can be divided to 2 parts. We need to figure out the first part. Let's start with the first part. Loading. Let's start with the slab. Anybody remember last meeting I told you we have 3 types or 3 kind of loading on a slab. The first one on weight, the second one sober, embossed, dead load, the third one life load. This on any slab, we have 3 kinds. You need to figure out these 3. Do you remember what was the on weight value? Thickness. Please don't forget your thickness will be divided by 12 to be n feet. Time gamma concrete. If you go back last meeting, I told you on weight for any slab, thickness time gamma concrete. So I think in this problem, your thickness of the slab is 5 inch. So I will divide it by 12 to be in feet. Gamma concrete, please remember this number all the time, 150 pound per cubic feet. So I can figure out the value of the on weight of this slab will be 62.5 pound per square feet. Your units is important. Please keep them with your number, pound per square feet. Sober embossed dead load, I think it's given. How much? 40 pound per square foot. Your life load is not given, but we have the function of the building theater lobby, so I can figure out the value of life load. How much? 100 pound per square feet. Do you agree? Any questions so far? Guys, any questions so far? Oliver, looks like you're writing something. Any question, guys? Okay, it's a good question, Oliver. Oliver, you didn't notice I told you I'm talking about slab only. I didn't talk about beam. I'm talking about slab. I'm talking about this portion of slab. And this is a good question. Your question is good. Your question is very good. I'm talking right now about this portion of the slab. I didn't talk about beams. Okay. But you are talking about a slab. That's right. But what about beam? Remember what was the function, the main function of the beams? What was the function of the beam? Beams to support slab. So the load on the slab must be transferred to the beam. That's right. That's right. Okay, my question is, what do you think? This beam is supporting from this center line to this center line. So this area of the slab will be assigned to this beam, and the same for each beam. So can you tell me what is the width here? I think it will be 8 inch. Yeah, from this center line to this center line will be 8 inch. So this surface load of the beam, which is, I can write it here. From slab, W dead load, W life load. How much? For W dead load, on weight is a dead load. Superimposed dead load is a dead load. So we have 62.5 plus 40. Your value will be 102.5 pound per square feet. Pound per square feet, that means on area. And your life load will remain the same, pound per square feet. So W for slab, dead load, W for slab, life load. I'm talking right now about beam. So your beam is simply supported with 20 feet span, will have uniform distributed load. W dead load and W life load. Let's start with the W dead load. W dead load will be this W dead load from slab, which is 102.5 times 8 feet plus 25 divide 12, 16 divide 12 times 150. W life load on the beam will be this W life load of the slab, which is 100 times 8 feet, and that's it, equal 800 pound per foot. Guys, before asking any question, we have W dead load and the W life load for the slab. If you multiply these values by this width, I can convert this surface load to distributed load on this beam. Do you agree? So the dead load on the slab, which is on weight plus superimposed dead load, multiply this value by width of the area assigned to the beam, I can convert this load to uniform distributed load on the beam. The same thing for life load. If you multiply this life load by this width, I can convert this life load to be uniform distributed load on the beam. So this life load from the slab time the width of the area assigned to the beam, I can convert this to be uniform distributed load. Any question for this point? Yeah. But the question is, we agree with this. But the question is, what do you mean by this part? Anybody can figure out what does it mean? What is the meaning of 25 divided 12 times 16 divided 12 times 150? What does it mean? Oliver, you are good. Melvin, you are good also. I need a specific answer on weight of the beam, on dimension of the beam, on weight of the... All of you are correct, but I need a specific answer. Oliver, you should figure it out. Okay, if you are saying on weight of the beam, but the beam overall depth is 30 inch. So why I used only 25? Perfect. Thank you, Oliver. Yeah, it's the remaining of your first question. Guys, if you go back, the on weight of the slab include all of this thickness. We still have part of the beam, which is this one. The overall depth of the beam coming from up to down 30 inch. And this thickness 5 inch. So the remaining part of the beam, which not included until this moment, will be this one, which is 16 times 25. And remember these numbers in inch, so I have to divide them by 12, and then multiply by gamma concrete. So if you add this part plus the dead load coming from a slab, I included everything, every dead load on the beam. So your final answer will be 1,236.67 pound per foot. And this one will be 800. Okay, thank you guys. So, W ultimate. We are on the final step right now because we converted everything to the beam as uniform distributed load. We have W dead load and W life load on the beam. So W ultimate will be 1.2 dead load plus 1.6 life load. Okay, 1.2, what is the value of the dead load? 1,236.67 plus 1.6, the value of life load, 800. so I can get a big number. This number will be 2,764 pound per foot. If you would like to make it more simple, it will be 2.764 kib per foot. We like kib. So guys, we have beam with uniform distributed load. How much? 2.764 kib per foot. And the span is 20 feet. Do you remember? Go back. Your bending moment looks like parabola. The maximum value, which is M ultimate, will be WL square divided 8. So W is given 2.764, L 20 square divide 8. Your value will be 138.2 kib foot. Here is the value of M ultimate. Here is the value of M ultimate. Guys, go back. We are looking for M ultimate to compare this value with the design moment. So what we did loading. It's called loading. What is the dead and the live load on the slab? How can we convert this load to the beam? What is the on weight of the remaining part of the beam? Then finally, we can figure out the bending moment on the beam, which called M ultimate. Why ultimate? Because you convert these loads to ultimate load by using combination and factor of safety, 1.2 and 1.6. Any questions so far? Any questions so far? This part is very interesting. To understand what's going on, you need to understand this point is very important. If you have a floor, how can I make my loading? I am live load. So my load will go to the slab. Then this slab, we have a part width of the slab assigned to one beam. So I can convert this load to a beam. We have on weight for the beam. Then I can figure out the bending moment on the beam. Second part of this problem, how can I figure out the design moment? So we have another problem. We have cross section. Remember, your cross section not rectangle, it's a T section. By the way, anybody can tell me what is the width, the effective width of this flange? Yeah, because you are talking about T section. Do you remember how can I figure out the P effective? We have three cases. We need to use the least one. The first one is span divide 5. The second one 16, I think H flange plus B width, probably. The third one center line to center line. Your span of this beam is 20. Remember to multiply it by 12 to be an inch, divide 5, so this number will be 48. This thickness, how much? 5 inch, so 16 times 5, plus this width, how much? I think 16, yeah, plus 16, so this one would be 96 inch. Center line to center line of the beam, I believe center line to center line is 8 feet. Please multiply it by 12 to be an inch, will be 96. The least value, so your P effective will be 48 inch. Any question, guys? We covered this before. As I told you, we have a long story. We are talking about long story. Each part is important. Yep, thank you, Oliver. Remember, the area steel is given. So we have here area steel, whatever. Your area steel, I think it's 6 number, it's 8 number 6. 8 number 6. So your area steel will be 8 times number 6. So I need to open what? A table for steel reinforcement number 6. What is the area of one bar? 0.44. So I can figure out the value of area steel. 8 times 0.44. Your value will be 3.52 inch square. We are in another problem. We are looking for design moment for this cross section. So I'm gonna assume neutral axis within the flange. So I'm gonna assume your neutral axis is here. I hope it's wrong. It's correct. It will make it more simple. So this part will be under compression. So your capital C will be 0.85 if you go back. F prime C, P effective A. And T, capital T, the tension in steel reinforcement will be area steel times F yield. Let's see. Let's see. Capital C equal capital T, so 0.85, 4,500 F prime C, P effective 48 times A, equal area steel 3.52 times F yield 60,000. The only unknown in this equation is A. What is the value of A? Wow, 115 inch. Please, I will do it one more time. I'm sorry. To be sure, I'm good.
Hey, Dr. Eggman.
Wait a moment. Yes, 1.15 inch. What's your question, Brock?
For the first case to figure out be effective, you did L over 5. Shouldn't it be L over 4?
Yeah, you are right. So you are reminding me right now. Okay, span divide 4. I'm sorry, guys. This number will be wrong. So 20 times 12. Thank you, Brock. Divide 4. It will be 60. Your P effective will be 60. So a little mistake will make a big difference. So this one will be 60. So your value of A, thank you, Brock. Your value of A will be different a little bit. 3.52 times 60 divide 0.85. This one will be 0.92 inch. Any other comment? Thank you. Guys, any other comment? You are right. Span divide 4, 16, thickness plus P web, center line to center line. Any comment here? Did your assumption is correct? Because you assumed the neutral axis within the flange. Do you agree? Yeah, because your depth of the neutral axis 0.92, which is smaller than 5 inch, which is a slab thickness, that means you are good. Your assumption is correct. Thickness. Anyway. So keep going. Your nominal moment will be area steel, F yield, D minus A divide 2.
Dr. Eggman?
Yes.
For your beta 0.85, since your F prime C is 4,500, wouldn't it be different number for beta?
Why you are looking for beta? Yeah, if you are okay, just a moment. A equal beta 1 times small c. That you mean beta 1? You are looking for beta 1, this one?
Right.
Okay.
Like,
I don't care about this equation right now. My concern is what is the value of A, the depth of the stress block, and compare this value with the thickness. If this value is smaller than the thickness, you are right. Your neutral axis within the flange, or your stress block within the flange. I know
okay.
the depth. I know the depth of the neutral axis is C, but I don't care about the depth, the actual depth of the neutral axis. My concern is what is the depth of this stress block? I need this stress block to be within the flange.
Okay. Let me ask you this. So your equation for C equals 0.85 times F prime C.
Yeah.
Is it 0.85 times F prime C, or is it beta 1 times F prime C?
No. This number is constant. This
Okay.
number is constant.
All right.
If you go back, I didn't say this number is beta 1 F prime C. I didn't mention this. 0.85 is a constant number. Beta 1 is used only for this equation only.
Okay. Thank you.
Okay?
Yes, sir. Thank you.
Okay. So area steel, how much the area steel? 3.52. F yield 60,000. Your depth, wow, depth is not given. The actual depth is not given. Okay, go ahead and assume any cover. This one, I'm gonna assume it like 2 inch or 3 inch. It's up to you, or 2.5 inch. Let's do it 2.5. And the total depth is 30. So this depth will be 27.5 minus A divide 2. Your nominal moment will be 3.52 times 60,000 times 27.5 minus this number divide 2. Your answer will be 5710848 pound inch. Divide it by 12. It will be 475,904 pound foot. Divide it by 1,000. It will be 475.9 kip foot. Do you think we are done? No. We are looking for phi MN, which is called design moment. Because MN alone is called nominal, theoretical value. So do you remember how can I figure out the value of phi? We have strain distribution. Do you remember? This value of strain on concrete is constant, 0.003. This depth called C. The remaining depth will be D minus C, and the strain in steel reinforcement epsilon tension or epsilon steel. Thank you. Do you remember all of this stuff? So A equal beta 1 times C. Value of A is 0.92. Value of beta 1. Actually, I cannot remember the value of beta 1. So I will go back to your second module, I think. No, third module. We have a table here in the third module. There you go. No. I'm sorry, guys. Second module. For beta 1. Here you go. So your F prime C equal 4,500. So I believe you are outside the first one. We are in the second one. So your beta will be 4,500 minus 4,000 times 0.05 divide 1,000 minus 0.85. Your number will be 0.825. So this value of beta 1 will be 0.825 based on the table in module number 3. Module number 2. Based on f prime c, I can figure out the value of beta 1. Brock, the value here is constant. I didn't mention this value is beta f prime c. No, this value is constant all the time, whatever the value of f prime c, 0.85. This is a different story, okay? So beta 1 based on this table and f prime c 4,500 is this number. So I can figure out the value of c, the depth, the actual depth of the neutral axis will be 1 inch and 11. So this one will be 1 inch and 11. So your depth 27.5, value of c 1.11. So I can figure out the value of this one will be 26.4 inch. This triangle looks like this triangle. So 0.003 divide this value epsilon tension equal this depth 1.11 divide this depth 26.4. So I can figure out the value of strain in steel reinforcement will be 0.071, which is greater than 0.005. So you, if you go back to module number 3, if your strain greater than 0.005, your value of phi will be 0.9. So phi will be 0.9. So go back, multiply this number by 0.9. 475.9 times 0.9 equal 428.31 kib foot. So guys, your design moment equal 428.3 and your ultimate moment from the structure analysis 138.2. $132.8, I think. That's right. 138.2. 38.2. What's your final decision? M ultimate smaller than design moment. Your beams are safe. Your beams are adequate to support this floor. Actually, we are more safe because the applied moment 138, but the resisting or the design moment can support until 400. So we are more safe. Probably we can decrease steel depth, concrete depth rather than 30 to be 25, probably decrease the amount of steel reinforcement, whatever the decision. But anyway, the problem asked for, do you think these beams are adequate to support this floor? Yes. So guys, if you are looking to this problem covering everything, all what we learned. How can we figure out the value of loads, dead and alive on slab? How can we convert this dead and alive load to a beam? How can we determine the rest part of the beam as on weight? How can we convert dead load and alive load to be ultimate load? Make combination. From structure analysis, what is the ultimate moment on the beam? From design, from concrete design, first step, what is the value of the effective? And we need to design this one. It's a T section. So I'm going to assume first step, neutral axis within the flange. Probably you are lucky in this problem, but probably sometimes you are not lucky because the value of A will be greater than 5. So you are outside the flange. So we need to try the second assumption, the neutral axis outside. Do you remember that one that I covered last meeting? We need to divide this part and then this part. But anyway, it's very long problem, but it's systematic. You need to understand each part in this problem. Yeah, it's long, I know. This is the reason I'm giving you a long time for the exam. So,
Okay.
yeah.
I think you just covered this on this last problem, but it's similar to the last problem we worked out last lecture. It was the very last problem on module number 4.
Yes.
Do you think you can go back to it really quick? I just have a quick question.
Okay, just a second.
If you can.
Yeah. Module number 4. There you go.
Okay. On this one, we went ahead at first and assumed our neutral axis is within the flange, correct?
Yes. Yes.
And then we got our A to be 5.95 inches, but our thickness is 4 inches, so it doesn't make any sense.
Yeah.
So you said, okay, so let's say if we worked it out and we assumed our neutral axis was actually smaller than the thickness of our flange, what do we do from there? Do we just go straight to finding MN?
Yeah, that's it. MN equal area seal, F yield, depth minus A divide 2. That's it. You are done.
Okay.
Like I did today. If you find your assumption is correct, like I did today, I assumed today.
Mm-hmm. Okay.
Yeah, today I assumed neutral axis within the flange, and I found my assumption is correct. I am done. Here is your MN. If your assumption not correct, you need to try the second assumption.
Okay, thank you, sir.
Okay. The second problem, exactly the same. Exactly. But your structure, I think, is different a little bit. I think your structure here is a passenger vehicles garage. So you need to figure different value of life load. So open this table. If you are talking about garage for passenger car, your life load will be 40. The flap thickness is 5. Area steel is given. Superimposed dead load is given. And the same question. And the area steel, 4 bars, number 11. And the same question. Are these beams adequate to support this floor system? So you need to figure out what is the value of M ultimate. What is the value of the design moment? To make this beam safe, your ultimate moment must be smaller than or equal design moment. The same sequence. Nothing changed. But your numbers will be different a little bit. So what do you think? So go ahead and try to solve this problem. If you have any question, let me know before Friday. But this one is a typical problem like this one, but a little bit different number, but the same sequence. Everything the same. For M ultimate. I started first, Roberto, I started first with loading with the slab. For your slab, we have 3 loads. You need to figure them out. On weight of the slab, superimposed dead load, which is given, and the life load based on the function of the building. Then your on weight and the superimposed dead load, both of them is dead load. So I add them together. Your life load is life load alone. So I am done with the first slab. What are the dead load and the life load on the slab? I need to convert these loads to be on the beam. So I'm looking for W dead load and the W life load on beam. So W dead load from slab will be multiplied by width. What is the width? As I told you, each beam is supporting a load from center line to center line. So this area will be assigned to this beam. So what is this width? And remember, your beam will still have another part of the beam. This little part. So I added the on weight of the beam. So here is the dead load on the beam and the life load on the beam. Once you get dead and life on the beam, I can figure out the ultimate load by multiplying dead load by 1.2, life load by 1.6. Once you get the ultimate load on the beam, your beam is simply supported with a span 20 and you have distributed load. I can figure out the value of moment. It's a story. You need to start first with a slab, then for beam, then combination W ultimate, then you can figure out the value of M ultimate. Yes, yes. On weight of the slab. What you mean by L equal 20, Roberto? What do you mean? Oliver, your question, yes. On weight of the slab is the thickness of the slab divide 12 times gamma concrete. Yeah, M ultimate equal W squared divide 12. The length of the beam is 20. If you go back to the problem, the beam spans 20 feet. And given on the problem, the span of the beam is 20 feet. So what's your question? And your moment from structure analysis, WL squared divide 8. So W and L and 8. So what's your question? No, it's not WL squared divide 12. It's a WL squared divide 8. I didn't say WL squared divide 12. WL squared divide 8. You got a different number? How did you get this? Divide 8. No, it's 138.2. WL squared divide 8.